Now we're going to take the parent graphs and we're going to manipulate them in different ways, and we're going to look at different patterns for what's going to happen here. So the first thing we're going to graph is the square root of x. So this one I'll graph without the help of a calculator. So 0, 0, 1, 1, 4, 2, and then the point at here at 9, 3. Okay, so this is the square root of x. To quickly arrive at some patterns, what we're going to do is use the graphing calculator to graph various things. So we're going to graph the square root of x, and it's going to be blue, and then I'm going to graph negative square root of x and see what that negative does. I'm just going to do a standard window. So what happened is it jumped to the opposite side, which makes sense. The negative made all those values negative. So we're going to graph the same thing just down here. Okay, now we're going to put a coefficient out front of 2. So I'm going to take my calculator and I'm going to replace that negative with a 2. Okay, so it got taller. So I'm going to trace to some specific values. I'm going to hit the up arrow, so I'm tracing the red one because I want to be tracing the 2 root x. And if I trace to 1, it's at 2. If I trace to 4, it's now at 4. If I trace to 9, it's now at 6. So what it's doing is it's dragging these points by a factor of 2. So it's still at 0, 0, but 1 is now at 2, 2 is now at 4, 3 is now at 6. Okay, if instead of doubling it, I make it have a coefficient of 0.5, the graph is now squished towards the x-axis. So rather than it be, so 0 is still at 0, but rather than it being at 1, it's going to be at 1/2. Instead of being at 2, it's at 1, and instead of being at 3, it's going to be at 1.5. Okay, and then the negatives, I'm not going to bother with the calculator. It's just going to flip those over the x-axis. So this is now going to be down here. And my last one is going to be negative 1/2. So there, there, and there. So now we're going to make a conclusion. So if we multiply the function on the outside, if it's greater than 1, it's going to stretch the graph vertically. It's going to pull it away from the x-axis. If it's between 0 and 1, it's going to compress the graph vertically. It pushes it towards the x-axis. And if it's less than 0, it's going to reflect over the x-axis. Okay, so our next parent function is going to be the step function. So I'm going to start by graphing the integers, as many as you feel like graphing. That's fine. And then we go to a closed dot to an open dot. Okay, then we're gonna graph this on the calculator, and the instructions for how you find this are here. So we're gonna go to our y equals, we'll get rid of those guys, and I'm just gonna graph the parent function for right now. So if you go to the math button, over to number, down to int, that is the greatest integer function. I'm going to close my window down a little bit, so I'm going to go from -6 to 6 in all areas, just so we can really see what's happening here. So then we're going to graph, and there's our little steps. It doesn't graph the dots, but... Alright, so now let's see what happens if we multiply by a 2 on the inside. I'm actually going to show you what it would look like if we did 2 on the outside. Okay, and then graph that just to verify what we saw on the first page. Okay, and it takes each of these little bars and it pulls them up. So the 0 stays at 0, the 1's now at 2, the 2's now at 4, and so on. Now, instead of the 2 on the inside or outside, I'm going to move the 2 to the inside to see the difference. So we still have bars at every level. There's still 1 at 1, 2, 3, 4. But rather than it affecting the graph vertically, it's affecting the graph horizontally. It's taking these bars and it's making them half as big. So let's sketch this over here. So 2, we're going to still start at 0, but rather than going all the way over to 1, our bar is going to stop at 1/2. Then it's going to go up and over, so it's every integer gets 1, but the bar itself is only 1/2 as big. This will continue back here. To that. Okay, now let's look at what happens if we, instead of a 2 on the inside, we put a 1/2 on the inside. Okay, now the bars are twice as big. They got stretched out. So now rather than going from 0 to 1, it's being pulled all the way over to 2. So we're going here, and it gets a little crowded on the inside here, but that's okay. Then we go up. And then backwards. Okay, these next two I'm not going to graph just because it would get a little ridiculous, but this one would make the bars 1/4 as big, so you'd have a little 1/4, 1/4, 1/4, 1/4 all the way up. This one would make the bars 4 units long. Okay, so if we multiply on the inside rather than the outside, it affects the graph horizontally. So if it is bigger than 1, it's going to compress the graph horizontally. If it is less than 1, it is going to stretch the graph horizontally. Next, we're going to look at absolute value. So absolute value would be right here. It's just a V. And we're going to look at the effect of adding and subtracting on the outside and adding and subtracting on the inside. So I can find absolute value in that same menu that we looked at before. So if I go to Math, Number, Absolute Value, and some of your calculators will show it as an absolute value. Some of them, it'll just be ABS. So we're going to do the absolute value of x, and then I'm going to do the absolute value of x plus 4. So we graph it. There's absolute value. There's absolute value of x plus 4. So it's going to be moved up 4. Okay, you can graph this on your calculator, but I suspect you will follow. This one's going to go down 4. Okay, next I'm going to look at what happens if we affect it on the inside. So here, on the inside of the parentheses, or inside of the brackets, I'm going to do plus 4. And graph. There's our original. And there's plus 4. Now this is a little bit counterintuitive. You want to think it's going to move to the right. But if you think about numerically, if I plug in -4 here, that's where my vertex is, because that's what's going to give me a 0. If I plug in a 0, I get 4. So this one goes there. My last one, and you can confirm this on the calculator, is going to go to the right 4 units. So what effect does C have on the graph? So if it is plus, it's going to be translated L up C units. This will be translated down C units. And I'm just going to copy this. This will go left C units. And if we subtract, it's going to be moved to the right. So here we're doing multiple transformations. So I'm going to let you give it a try. If you want to pause and do those graphs. So I'm just going to label these A, B, no, sorry. We're going to look at these ones and label these ones A, B, and C. So this one is going up 4 and to the right. So this one is A. This one's going down 4 to the right. So this one is B. This one is to the left 4 and up. And this one's to the left and down. So when you're describing the transformation, you would just say this one goes right 4 and up 4. This page, we're going to take this generic graph and do some reflections. So this first one, if I graph negative f of x, we've already talked about that. It's going to take this graph and flip it upside down. So if we take all of the y values and flip them, so from this graph, this one is going to be pulled up here, this is going to be pulled down here, and so on. The resulting graph looks like this, and we can describe it as reflected in the x-axis. If it's f of negative x, it actually takes everything and reflects it over the y-axis, because it treats a 2 like a -2 and a -2 like it's a 2. So if you compare this graph to the one above it, everything just gets reflected over the y-axis. The next one we're going to look at is the absolute value of f of x. So anything that was positive is going to stay positive. But anything that is negative, these areas, those are going to be reflected up. Negative will stay 0. All these negative ones are going to get reflected up. So here's what that graph would look like. The things that were positive stay positive, but anything that was below the x-axis gets reflected over. The last one's a little bit trickier. It's f of the absolute value of x. So what it's affecting is the x values. So it's going to, if I plug in f of 10, it's going to stay the same as f of 10. So this half of the graph is going to look exactly the same. But if I plug in an f of negative 10, it's going to change it to f of 10, and it's going to give me a value of 2. So what's going to happen is this graph is going to get reflected over. So there's still negative values on the graph because the function itself isn't the absolute value. It's just taking those values and reflecting them over. So here's all the transformation just summarized in one place. This will also be on the online notes as well. So you can pause this and jot this down if you want them all in the same place. Okay. In these last problems, we're going to identify the parent graph, describe the transformation, and then graph the function. And I'm going to graph both the original and the new one. So for this first one, the parent is y equals x squared. Okay, and there's two things affecting it, the 3 and the minus 2. So the 3 is going to stretch it vertically. The minus 2 is going to move it down 2. So I'm going to graph my original one, my parent function. And you can do either of these first. Okay. The whole graph is going to be moved down 2. So it's going to be started down here. But the next one, rather than going over 1 and up 1, it's going to go over 1 and up 3. Same this direction. And then rather than going over 2 and up 4, it's going to go over 2 and up 12, which puts it all the way up at the top of the graph here. So this one just ends up appearing much skinnier than the other one. Our next one, negative 2 square root of x minus 4. So my parent is y equals root x. So that graph is like that. There's three things. The 2 is going to stretch it vertically. The negative is going to reflect it in the x-axis. And the minus 4 is going to move it to the right 4. Okay, so my first point is going to be, rather than starting here, it's going to be starting over 4. So the next one would be up 1 over 1, then stretched by a factor of 2, then reflected over the x-axis. The next one would be from here 4 units out, up 4, but reflected. And you can always plug in values if you're kind of stuck. Next is a step function. So my parent is that guy. So close to open, close to open, close to open. Like so. But I missed one. That should go right there. So that's fine. Okay. This one only has 1. It's going to be moved to the left 4. So this one is going to be moved over 1, 2, 3, 4, and then I'll just go from there. This one at first glance looks like the absolute value might be the parent function, but the parent function here is actually y equals x squared. I'm going to graph y equals x squared minus 3, and then we'll talk about what the absolute value is going to do to that. So y, that would be moved down 3. Okay, so this would be the inside of this. What the absolute value is going to do is it's going to take the negative stuff and reflect it. So this part of the graph is going to stay the same. This is going to get flipped over. So if I plug in 0 into this, I'm going to get a -3, but then it becomes the opposite value of that. So this whole thing ends up looking like a W. That is families of graphs.